I'm going to also show you a method to optimize, if you're using exponential smoothing, how to optimize the alpha constant value, because we have to select an alpha value between 0 and 1. We don't have time to go through all possible values for alpha and then see which alpha value is going to give us the best exponential smoothing forecasting method, right? So there should be a way to select alpha. So in that case, we are going to use optimization tool, Excel's optimization tool, which is Excel Solver, that should help us identify the appropriate alpha value. Okay, so how does it work? Basically, you're going to treat alpha as the uncontrollable or decision variable, right? It's going to be the one that we have to decide, or the model has to decide for us. For example, if you would like to minimize MAD, you have to treat this as a function subject to the constraints below, which is alpha should be less than or equal to 1 and should be greater than or equal to 0. And then we will have to do the same thing for our objective function. Well, right now our objective function here, it is MAD. If you would like to minimize MAPE, you have to put MAPE formula here. If you would like to also minimize MSE, you have to put MSE formula here as well. So this is for the weighted method. For the moving average, I will explain both our Excel files here, right there. Not this one. It's the title of the Excel file that we have to use Excel Solver. It's called Solver Forecasting Excel, right? So please download this from the Blackboard Lecture 5 Forecasting, and then open it up. It should give you exactly a template that you can work on. So here, these are the monthly burglaries values for a specific month. Okay. Here we have our alpha value. Okay, currently specified to 0.5, and our error, our relative error. We need these two columns to calculate MAD, MSE, and MAP. So let's check out how to find the optimal alpha value. So for example, here alpha is 0.5, right? So if you can just make it 0, the whole equations, they change. If you make it 0.75, the entire equations, they're going to change. Obviously, MAD, MSE, MAPE, those are going to change as well. Well, okay, what should alpha be so that we can say, hey, okay, please go ahead and take this alpha and use it? Well, the answer is using Excel Solver. So by doing the same thing, just make sure that if you don't have Excel Solver on the Data tab, okay, go to Data tab and then locate your Excel Solver on the right top side, right? If Excel Solver is not here, go to File, Options, Excel Add-ins, one more time, click Go. Make sure that your add-ins, the checkbox next to Excel Solver add-in is checked. If you do that, your solver should pop up right here. Well, click on it. Okay, so this is the solver interface. It says set objective. So what's our objective? Our objective is to minimize the error value. Right now I'm just going to say, hey, give me the best alpha value that minimizes the MAD. Okay, I selected MAD. And I'll select minimization. I'm not going to select maximization, right? Because I would be maximizing my error. That's something that I don't want to do that. Okay, I will minimize the formula that I have here by changing variable cells, exactly the alpha value that I use here, right? I'm going to change the alpha value so that I can get the minimum MAD value. It says subject to the constraints C4, which is this one less than or equal to 1, and C4 is greater than or equal to 0. How to do that? I'll just first get rid of them and show you how to do that. You can do this by clicking on C4, selecting the appropriate constraint, the symbol, less than or equal to 1, right? We'll have to add one more, C4 greater than or equal to 0. Click OK. And I say make unconstrained variables non-negative, just to make sure that alpha value is going to be non-negative. And as a solver, I will just go ahead and select GRG nonlinear because MAD is a nonlinear function, as you can see here, so I have to select GRG nonlinear. Pay attention to C4 because Excel is going to change it, right? Click solve. There you go, it is 0.64, right? Click OK to keep the results. Well, let's see if this changes to a different value if we would like to minimize MSE. Okay, let's do the same thing, click solver, but this time my objective is not MAD. I would like to minimize MSE by keeping the same changing variable cells and the same constraints. Let's see what happens. Well, it goes down to 64 because if your objective is to minimize MSE, the best alpha value to use is 0.63, right? Okay, let's do the same thing for MAP. Now my objective is C25, everything else is the same. So, well, my alpha value went back up to 0.64, so I will just stick to 0.64 because 0.64 is going to minimize both MAD and MAPE. Okay, this is how you select your alpha value. Okay, you don't have to try several values for alpha and then find the best alpha value. You can just do it by using Excel Solver very easily. Okay, I showed you earlier how to do weighted method for moving averages. So if our weights are currently 0.6, 0.3, and 0.1, right? So let's see, 0.6 is B2. B2 is used for B7. B7 is our most current month, so I'm dedicating 0.6 or 60% weight for my most current value, and then 30% for my second most current, and then 10% value for my third most current values, right? So if you keep doing this, it is the same structure. The weights are going to remain the same, but the observations, the boundaries are going to change because the time progresses. But what you are doing is that you are taking the most current 3 time periods, you are assigning 60% of weight to the most current one, 30% weight to the second most current one, and then the 10% weight to the third most current one, right? And then you're getting yourself a forecast. Well, for forecast, you just need to calculate MAD, MSE, RMSE, and value. Okay, the key question is, how am I going to select these, right? What should that be? Okay, what should be the value for W1, W2, and W3? Remember, the sum should be equal to 1, right? Well, we are going to use Excel Solver for that as well. Here, if you click on Excel Solver, again, our objective is an error value. In this one, it is already selected as H25. H25 is our MAD, right? You can select MAP, MSE, or whatever. Okay, well, I will stick to MAD. It says the changing variables, so which ones that we are going to decide. The changing variables are going to be W1, W2, and W3. These are the values that I will want Excel to play with so that I can get the minimum MAD value. And the rules should be, these guys must be less than or equal to 1 and greater, the sum of these W1, W2, and W3 should be exactly equal to 1, right? And then these individual weights, they have to be also between 0 and 1. Okay, this is what these constraints are. I'll just delete them and then add them one more time so that we can see how they work. Okay, so click add. Since these guys are next to each other, I can just go ahead and select them. Okay, and say less than or equal to 1. I will do it one more time, select them, and then make sure that those are greater than or equal to 0. And then I will go ahead and say that the sum of these 3 must be equal to 1. Click OK. As you can see, those three constraints are already added there. Again, make sure that your GRG nonlinear solver is selected. If you hit solve, say solver has converged to the current solution, all constraints are satisfied. Thank you so much for doing that. Click OK. As you can see, third most current one is 0. The solver, the optimal solution, is only using 3 most current data points, and it assigns 83% to the most current data point and 16.2% for the second most data point. By that way, our MAD is going to be minimized. Again, if your objective is, for example, to minimize MSE, let's see what happens. All you need to do is to come here and then select MSE as your objective and click solve. Interestingly, if your objective is to minimize MSE, now your W3 is around 2% or 3%. It's using it, but it's slightly using it compared to the previous one. Okay, as you can see, the sum is equal to 1, and then our constraints are that these W's are less than or equal to 1, and those are all greater than or equal to 0. So those are also satisfied. This is how you got optimal weights if you are using moving average method for the forecasting methods. Okay, so in summary, you don't have to try these out one at a time. You don't have to try a specific number for these weights. You can just use Excel solver to select the best ones out there for you. It is guaranteed that these weights are going to minimize your objective function. In this case, it is MSE. Previously, it was MAD, right? Depends on whatever value you put in here. Okay. Similarly, for exponential smoothing, it is going to give you the best alpha value based on your objective function value, right? So MS Excel solver is very effective, and it's a very efficient method to do this kind of analysis. All right. So thank you for watching. I will see you in the class.